Hey everybody, Harold here. Today I'm going to start a short sub-series of this Mastering Python Libraries on the collections module, and it's got a bunch of data structures in it, and I'm going to do a video for each one. The first one I'm going to do is the deck. Python collections deck, or double-ended queue, is it's like a list, but it's optimized for fast appends and pops from both ends. So it's an object in it. You don't have to iterate through it. So from collections, import deck. A simple deck is a tuple. You create it with the deck function. So simple deck, D equals deck, tuple 1, 2, 3, 4, 5. And let's just show you D, deck, the object deck, 1, 2, 3, 4, 5. The first thing you can do is append to the right. So D dot append 2, then print D. So 1, 2, 3, 4, 5, 2. Sure, that's easy with the list. You can also append to the left. So D append left 42 and print D, the deck 42, 1, 2, 3, 4, 5, 2. You can pop, that's going to come from the right. So D dot pop, no argument. 42, 1, 2, 3, 4, 5. It popped the 2. D dot pop left. It popped 42. Then we're back to our original 1, 2, 3, 4, 5. There is an argument here you can use with it called maxlen. If you set that, it'll pop the element at index 0. If you append, and it'll pop the last element if you append left. So let me show you that. So I'm going to deck 1, 2, 3, 4, 5 and append 9 to it, but I'm going to say there can only be 5 numbers in my deck. So D2 is now 2, 3, 4, 5, 9, because I appended to the right, it popped the left, the 1. If I want to append left to if I want to append 11 to the left, it should still keep the list at 5 and pop the 9 from the front. So 11, 2, 3, 4, 5. Now, if you want to add more than one element, you can add a list iterable and extend to the right or the left. So a deck of 1, 2, 3. I want to extend it to 4, 5, 6 to extend 4, 5, 6. 1, 2, 3, 4, 5, 6. I want to extend to the left. D3 dot extend left. 0, -1, -2. So that put -2 to 6 is now on my deck. So you can add things to both ends. That's the great thing about the deck. If you want to realign your deck a little, you can rotate it. It brings the last n number of elements to the front. So D rotated equals the deck 1, 2, 3, 4, 5. Okay. D rotated dot rotate 2 should bring 4 and 5 to the front in that order. So now it's 4, 5, 1, 2, 3. If I said D rotated 1, it would just bring the 3 to the front on that one because it's already rotated. And if I rotate again, it'll bring the 2 to the front. Rotate 2, and it'll bring 5, 1 to the front, etc. So that's rotate. Reverse lets you reverse the deck in place. Little typo there. So D reversed equals deck 1, 2, 3, 4, 5. And then I'm going to reverse D reversed and print it. So it's 5, 4, 3, 2, 1. Insert, you can do it. It's not efficient. It's append and pop. It's operational complexity in. So D insert the deck 1, 2, 3, 4, 5. I'm going to insert 4 at index. So it's index and what you want to insert. Insert 4 at index 2. Should be 3. 1, 2. So 4 was inserted. That's not as efficient as the push, pop, reverse, and rotate. You can take one out. It will remove the first occurrence of whatever you put in the argument. So it's D dot underscore rim dot remove 3. It's going to take out the first 3. So you have 1, 2, 3, 3, 4, 5. So it's 1, 2, 3, 4, 5. You want to clear the deck? Dot clear. D underscore remove dot clear. And you have an empty deck. You can count what number of values in the deck. So these are all duplicated at least once. So I want to count how many 4s are in the deck. There are 3 4s in my deck. I want to count how many 5s. There are 5 5s in my deck. So that's the methods, and let me now show you a good use case for it. I want to import time for this. So let's create an empty jobs queue. Deck jobs equals deck, empty deck. Print it for you, deck, empty deck. Assign some jobs to the queues. Retrieve the messy data, send it to the inbox, clean the data, and send it to process file. So we're going to append all those jobs to the queue. And so they are in order. Retrieve messy data, send to inbox, clean data, send to process file. Now, the machine is going to process the jobs while there are any jobs left in the queue to do this. So while there's jobs, it's going to pop from the left, process the job. This is just for effect, time sleep 2. And when it's done, it's going to print queue empty, processing complete. Processing job, retrieve messy data. Processing job, send to inbox. Processing job, clean data. Processing job, send to process file. Queue empty, processing complete. Now you could add more jobs to the front of the deck while this is going on and keep it rolling. And so you can work on both ends, and that is the beauty of the deck. Hope you liked this video. Hope you got something from it. If you did, please like and subscribe, and I'll see you next time. Thanks, everybody.